This video is going to focus on graphing quadratics in vertex form. Now, previous to this, I've given instruction on how to graph a quadratic equation in factored form. You can find that in another video. We've also given instruction on how to graph in standard form, and those two forms are in the same video. So here's an example of factored form. Factored form has two binomials, which are the factors of a trinomial, but we know how to graph this because there's specific information shown to us here. How we would find the roots, how we would find the axis of symmetry, and the vertex and things like that is different in factored form than it is in standard form, where you have an x squared term, an x term, and a constant. So we know how to do both of those, and if you're unsure or you need some additional reminders, you can watch the other video. In this video, we're going to focus on the vertex form. Okay, and it is special because it provides us the vertex as soon as we look at the equation. So if we think about just the regular form here without any numbers, just the variables here, the h and the k are going to provide us the vertex. The a is going to tell us how stretched out the graph is going to be. So if the value of a, well, the absolute value of a, is larger than 1, then we're going to have a really narrow parabola. It's either going to look like this if it's a positive a value, or this if it's a negative a value. So I'll say a plus and a minus, obviously, but if it's larger than 1, that's why it's going to be skinnier. And if the absolute value of a is less than 1, but between, well, I'll say between 0 and 1, like if it's a fraction. So for instance, if we have a 1/2 in our a spot right there, then it's going to be a wider or more open curve. So it could look more like this or more like this. Okay, so it's a much more open kind of parabola. So what's special about this form right here is that h and k are the vertex. So we do get the vertex out of it right away, where in this form or in this form we have to do a little bit more work, right? We'd have to average the two roots to find the axis of symmetry, and then plug the axis of symmetry in to find the vertex. In this case, we would use the negative b over 2a to find our axis of symmetry, and then we would have to plug it in to find the vertex. But this has the vertex for us, okay? And that's pretty much all it has. It also has, obviously, the axis of symmetry, which is the h value. Now, when we think about the vertex, though, we have to remember that there's a negative sign right here. The negative sign could also be read as the opposite of that value. So what I like to remind my students of is that h is always the opposite sign. Okay, so let's go ahead and try one of these. Let's try one out and see if we can remember some of the important things we know about a parabola. But now that we have this form, how are we going to handle those things? So the vertex, remember, is just going to be hk. And in this case, it shows that it's positive, but of course, because we remember that h is always the opposite sign, our vertex here is going to be -5. That's our x value. And k is always the value that's shown there. It's not the opposite. So let's go ahead and plot this at -5, -2. Another thing we want to remember is whether this curve is going to be opening up or down. If we have an a value of +1, which we do here, then that means that we're going to have an upward facing graph when the a value is positive, okay? Now, one of the next things we want to think about is, where's the axis of symmetry? Well, we already know that the vertex is really just called the minimum or the maximum, right? It's the highest or lowest point on the curve. In this case, because we're going to have this upward facing curve, it's going to be a minimum, and the minimum is going to sit on the axis of symmetry. So the axis of symmetry is going to be where x is equal to -5. Now, the next thing we have to do is we have to plug in values of x that are close to the axis of symmetry. Okay, so close to the axis of symmetry would be like -4, -3. Those would probably be pretty close. And what I like to have my students do is make a little table. The first point I'm going to put on here is my vertex. And then I'm going to pick out some values that are close to the axis of symmetry to plug in. So let's say -4. Okay, I'm going to plug that right into the equation. So y is equal to -4 plus 5 squared minus 2. Okay, so obviously this is just +1 squared. 1 squared is 1 minus 2. So my y value is going to be -1. And so I can go right here and plot that point. Just remember that if I plot that point, I would have a reflected point on the other side of the axis of symmetry. So now I have a point -6, -1, and I'm just going to write here this was reflected. So I plugged in the -4 into the equation. Okay, now I'm going to plug in one more point because I'd like to have at least 5 points on here to show a really nice smooth curve. So another point I could plug in is maybe -3. So y is equal to -3 plus 5 squared minus 2. And when I plug that in, I get +2 squared minus 2. And that's just 4 minus 2, so that's going to be 2. So now I have +2, and I can also plot a point 2 units on the other side of my axis of symmetry, and that's going to be -7, +2. And remember, I plugged this value in to get this value out. Now I can go ahead and connect those points and make my nice smooth curve. Some of my students forget to put the arrows on the end of their graph. Make sure you do that because, of course, these continue on indefinitely, even though we're not plotting all those points. Okay, I would like to show you another example. This example is going to be a little bit different only because it's negative. Okay, so let's take a look at this one. I have example 3 here. So my equation is in the vertex form. So the first thing I'm going to notice is that it's downward facing because my a value is negative. And it's also a number that's bigger than 1, so I know that this is going to come out kind of skinny-like. I am going to find the maximum as my vertex. My vertex is going to be -2, +3. Those are the h and k values there. And then, of course, my axis of symmetry is just the x is -2 because the value of x here gives me my axis of symmetry. So I'm going to go ahead and plot that. And I'm also going to plot my vertex, which is -2, +3. And then I'm going to start plugging in some values that are close to -2. And I'm going to create a table. My first point is going to be my vertex. And then something close to it is -1, so I'll go ahead and plug in -1. And again, I'm just plugging it into the actual equation where x is. Now, this is going to be important, but because of the order of operations, remember we want to do the parentheses first, exponents, and then we'll do the multiplication and addition. So the other thing I suggest sometimes to my students is to go ahead and write this into your calculator. You could use Desmos calculator if you don't have a handheld calculator. If you have an internet, then you can just go to the desmos.com/calculator and type this information in. So -3, and this is going to be +1 squared inside the parentheses there. 1 squared is just 1, so I'm going to write it over here. -3 times +1 plus 3. Now again, you have to go in order here. So -3 times 1 is -3, plus 3 is 0. So we found a root. Now, how do we know we found a root? Because, let's see, right here, because that's an x-intercept. So that's also called a root, not necessarily what we think of when we're doing the vertex form, but in our factored form we know about x-intercepts. And I'm going to plot a point on the other side of that. So that's going to be negative 3, 0. And then I'm going to pick one more number, and that other number is going to be 0 since it's pretty close to it. And so I'm going to go here. Don't forget, you have to include the a value when you're doing these calculations. 0 plus 2 squared plus 3. And again, we want to make sure we do our order of operations correctly, or just use a calculator so that you don't mess it up. Okay, so 4 is my 2 squared times negative 3, which is negative 12, plus 3. So my y value when x is 0 is going to be negative 9, which is down here. Okay, so when x is 0, my y value is negative 9. So that's another place we could say, well, that's the y-intercept, right? That's where the graph crosses the y-axis. And then, of course, I can plot on the other side of the axis of symmetry. So that is negative 2, negative 4, negative 9. And now I get to connect these and put arrows on the end. So as I mentioned at the beginning, because my a value is greater than 1, it's a much skinnier curve. Okay, now if you take a look at example number 4, which I'm not going to get into, but right here, you should be able to tell that because the a value is 1/2, we would have a much wider or much more open curve. Okay, so that is all you really need to know about graphing in vertex form. I was going to show you my graph for that example. Example number 4, where the graph is, it's upward facing because it's positive, but because a is 1/2, we have a much more open curve. Okay, and I would definitely suggest adding your x values into a calculator to figure out your table and plot those appropriately. I hope you found this video helpful. Come back next time for another great math video.